Welcome to section 11.1, Roots and Radicals. Radical notation consists of two pieces, not counting the actual radical sign. The first piece, n, is called the index of the radical. The second piece, the expression or number under the radical sign, is called the radicand. The symbol is actually read as the nth root of x. The meaning of the nth root of x, assuming that x is a positive real number, the nth root of x is also the positive real number such that when the nth root of x is raised to the n power, you get x back. When the index is not written, it is understood to be 2 and is called the square root of x. The square root has the property that if we take the square root of a squared, we get the absolute value of a. For example, if we take the square root of -3 squared, this actually turns out to be 3. So the absolute value of -3 is 3. If we take the square root of 3 squared, then we still get the absolute value of 3, which is still 3. Sometimes square roots are not real numbers. For example, if we try to take the square root of a -4, this won't be a real number because a negative times a negative would be positive. Because remember what this number represents. If we take the square root of -4 times the square root of -4, then we get -4. But because a negative number times a negative number is positive, and a positive number times a positive number is positive, it's not possible to multiply any real number by itself and get a negative number. So therefore, the square root of -4 cannot be a real number. For example, suppose we were asked to evaluate the square root of 4. One way to do this is to ask ourselves, what positive number can we multiply by itself to get 4? The answer, 2. 2 times 2 is 4. A second way is to simply use a calculator with a square root button. For example, if we had to evaluate the square root of 39, in this case, we have to use a calculator. There is no integer that we can multiply by itself to get 39. So the best that we can do is a calculator approximation. The square root of 39 is approximately 6.24499799898. Suppose that we are asked to evaluate the third root or the cube root of 8. Again, we ask ourselves, what real number multiplied by itself 3 times gives us 8? We can realize that 2 times 2 times 2 is 8, so the cube root of 8 is 2. A second way to evaluate this would be to use a calculator which has a yth root of x key. If your calculator has one of these keys, I point you to the manual for help in actually using this key. Suppose that we are asked to evaluate the cube root of 119. Again, there is no nice real number that we multiply by itself 3 times to give us 119. So we are forced to use a calculator approximation, for which the cube root of 119 is approximately 4.918684734. Suppose now that we are asked to evaluate the cube root of 8/27. Remember that when we are multiplying fractions, we multiply numerators and we multiply denominators. So we need to number that multiplied by itself 3 times gives us 8, and a second number that when multiplied by itself 3 times gives us 27. We have 2 to the third power gives us 8, and 3 to the third power gives us 27. Therefore, the cube root of 8/27 is 2/3. Suppose we are asked to simplify the square root of the quantity x plus 5 squared. Since we have the square underneath the square root, we use the absolute value relation. So the square root of the quantity of x plus 5 squared is the absolute value of x plus 5. If we are asked to simplify the square root of x squared minus 8x plus 16, we first realize that x squared minus 8x plus 16 is a perfect square. It is x minus 4 squared. Again, we can use the absolute value relation, as we did in the previous example, to obtain the final answer of the absolute value of x minus 4.